behave yourself.
And the sooner I start recording. So I want to talk about the unit tangent, the unit normal, and the binormal, which is also has the length of 1 unit vectors. And give you some examples. So let's recall the definition of the 3 from last time. All right, the definition, if you recall. So the unit tangent vector, we have 2 ways to express it. Actually, we're going to express it as the derivative vector r prime of t divided by its magnitude. That's pretty much a very simple definition. So this is the unit tangent vector. Likewise, the unit normal vector is also a derivative vector divided by its magnitude, except in this case we take the derivative of the unit tangent vector. So it will be t prime divided by the magnitude of t prime. And the third one in this holy trinity of vectors, the binormal, defined as the cross product of the tangent unit vector and the normal unit vector. So this is binormal. And although I didn't write it, because you have a magnitude of 1 cross multiplying a magnitude of 1, the result is also unit vector. The way they work together, as I said, they follow the right-hand rule, and if you let the thumb be perpendicular to the index finger and the middle finger perpendicular to both, this will be the arrangement of the T and B. And when we graph it, sometimes we call it the T and B frame of graphing a 3-dimensional curve. So assume that the center, there is a point sitting right here at the connection of the 2 fingers, and assume that the thumb is also connected to this point. So as you travel through the curve, you have the tangent to the curve. So let's say the curve is heading this way. The normal to the curve is perpendicular to the tangent, and the second normal, or what we call the binormal, is also perpendicular to the tangent, but in the other dimension. So so that we'll have this right-hand rule arrangement. Okay? So basically, if you sketch it, and here's your curve in space, right, and so this is curve C, and you have some kind of point right here, then this will be the tangent in the direction of the curve. This will be the normal, and I should draw it as if all, to reflect that all have the same length, and the binormal is going to sit, again, T, N, and B, so it will be right here if I follow the right-hand rule. So this will be the binormal, such that you have a 90-degree here, you have a 90-degree here, and of course you have a 90-degree between T and N. Okay? And remember, this is a function of T, so P can be also a point in time moving along a certain spatial or 3-dimensional curve. I have 2 examples to give you before we move on to the next section. One, I'll take you back to the curvature, and in this example we have a position vector r of t given by the component t, t squared, and t cubed. Okay, what we need to do, we want to find its curvature. Remember, curvature K at the origin. So that kind of makes it easier. And let's recall the definition of the curvature. And this is the curvature as a function of time. So we said that the curvature has two representations. The curvature, being a scalar, is the irrational function or irrational expression where the numerator is the magnitude of a cross product of the first and the second derivative of the position vector r. And all of those are r of t, so that's why it's still going to be k as a function of time. And this is the magnitude. Okay? So it's r prime cross product r double prime. The denominator is the magnitude of r prime raised to the cubic power. So even though it's a cumbersome expression, we're going to use that. But at time, we'll have already the tangent unit vector available to us, and we can write it in terms of the unit tangent vector. So we have it as the magnitude of t prime divided by r prime, like so. And that's the alternative expression that we have for k. Okay? So we'll use the cross product. So to start with, we need to find the cross product. So r cross r double prime. Okay? So I'll jump into the ijk, and we can take the derivative. So the first derivative will be 1, 2t, and 3t squared. And r double prime will be 0, 2, and 6t. Okay? And now we'll take the we'll do the cross product. So the component of I will be 2 t times 6t. That would be 12t squared minus 2 times 3t squared. So 6t squared in the I direction. What about the j direction? It will be simply negative 6t minus 0. So negative 6t in the j direction. Okay? And in the k direction, we have 2 minus 0, so plus 2k. Okay? We can write it as a vector component if you want. Ct 6t squared comma negative 6t and a 2, like so. So we have we almost have the top part. The remaining thing to do is take the magnitude of the top part. So the magnitude of the cross product r prime and r double prime is simply the square root of what we had before. So it will be 36t to the fourth plus 36t squared plus 4, and you can see that we have a common factor. Can I remove this page, or still working on the previous page? 1 second. All right. Anyway, you see that the common factor is 4, so square root of 4 is 2, and you have 9t to the fourth plus 9t squared plus 1. Okay, let me remove this plate, bring it back right here. So this is the top part. What about the bottom part? Well, r prime, the magnitude of r prime will be simply the square root of 1 plus, what do we have? 4t squared and plus 9t to the fourth, isn't it? So now we can construct the expression for the curvature. The numerator is 2 square root of 9t to the fourth plus 9t squared plus 1. And the denominator, remember, this is the magnitude of r prime cube. So we'll have, I'll go with the polynomial in ascending order. So 9t to the fourth plus 4t squared plus 1 raised to the power of 3/2. Okay, and now at what is the value of t at 0, 0, 0? Go ahead. T equals what? 0. So k at the 0, k of 0 will be simply 2 times 1 divided by 1, so it simply equals 2, and this is the result. Okay? So in your homework, before, I put this comment prematurely because really the homework problem is a two-dimensional curvature. So, and we have simplified results for two-dimensional. So let me remove this comment. As I said, it's a little bit premature, and write the following. And this is a follow-up. So curvature of a two-dimensional curve, of a plane curve. Okay. What is the difference between what we did so far with the curvature and when we have only two-dimensional? Well, a two-dimensional curve, a 2D curve is expressed, is given by y equals f of x. Okay, this is what we call the real valued function compared to vector valued function. So if we want to write it in a parametric form, we let t equal x, right? And we let y equal f of x. And then the vector r in two dimension, we can write it as the vector x f of x 0. Okay? Or you can write it as x in the I direction plus f of x in the j direction. So what is r prime? Well, take the derivative. R prime will be 1 f prime and 0. And or we can write it as I plus f prime j. Okay? It was the voice from outside. And we need r double prime. So let me write it here. R double prime will be 0 f double prime 0 in the component form, or it will be 0I, and all you have is f double prime j in the ijk notation. And now we can go ahead and perform the cross product as we did before. Okay. So if you do the cross product r prime cross r double prime, then we have the ijk notation, and r prime will be 1 f prime 0, and double prime will be 0 f double prime 0. And you can see that of all the component, we have the only surviving component will be the k component. Because if you look at the I component, you have f prime times 0 minus 0 times f double prime. So you have 0 on the I component. J component, negative 1 times 0 minus 0, so 0j. K, you have 1 times f double prime minus 0. So the result of the cross product will be simply the component 0, 0 f double prime, or we can write it as f double prime k. Okay? And the magnitude, we for the denominator, we need the magnitude of r prime. So the magnitude of r prime is simply the square root. This is r prime, remember, I plus or 1 f prime. So it would be the square root of 1 squared, or 1 plus f prime squared, like so. Okay? And the curvature now becomes the following expression. Again, k is r. I'm writing it so, and you want to write it even though you have it already, just to help yourself memorizing it, if you like to memorize stuff. So the result on top will be simply if the magnitude of the cross product is simply f double prime. And remember, and this is all function of x. And here you have 1 plus f prime squared cube, like so. Now this is the square root, so to the 3 halves, like so. And this is a shortcut. Now, my comment, this is what you follow this example to complete homework number 10. Now, this is the place to write it. So, follow this example to complete homework 13.3, number 10.